then become irrational. And then later on, because they realize that, oh, okay, with this in hand, we can actually define the big guy. The big guy is R, which is the set of real numbers. So it contains everything. So everything that is rational, irrational, integers, and so on and so forth, they all belong to, they all under. So this guy here is the real Mahoya, is the set of real numbers where it contains everything. So everything now it become real. And then I think later on, after I will stop about sets here. Later on, after when we go towards chapter 4, you will discover that there is another set which is bigger than even the set of real numbers, and we call it usually the set of complex numbers. So I will introduce that one at a later stage. Okay, now that we know, we just remind ourselves of the notions of sets. So which means that you can see a set just like a box. Usually you call this an Eigen diagram. So it looks just like a box. So usually you call an Eigen diagram. So if I call it, I can give it the name A. So it could be like a big set or it could be a smaller set. If a smaller set is inside it, so let's say A has another box inside or another bag inside, so which I gave it the name B, then B will be called a subset of A, and so on and so forth. We're going to introduce the notions of set theory later on that we need for the linear algebra. Now, for now, we're going to move to the definition of system of linear equation. Now that we know the numbers, we can see what we do. So let's say we have x. At school, you all learn that if you have x minus y equal to 1, and then x, let's say, plus y equal to 2, so you all learn to know that this is a system of linear equation. Sometimes it's written like this, sometimes it's written with a curly bracket, or mathematically we call it a brace. So this is known as a simultaneous system of two equations and two unknowns. Are you guys all with me? So now the question come in that adversity generally, here for this in high school you generally you have so many methods of solving them. Among you use the substitutions, you use the eliminations, you use the combinations, you use the Cramer's rule, and so on and so on and so forth. There are so many ways of solving them, and then when you solve, you're going to get a solution, which is I'm going to call it A and B. I'm not sure if that's the correct. So and the solution is going to be like a pair of the value you get for x and the value you get for y, right? So you call that pair the solution of the system of linear equation, or you call it the solution of the simultaneous system of equation. So now these equations, they are in adversity, we call them system of linear equation. And the idea why we call it linear, if you see here, x is like with a power 1, y is actually with power 1, x with power 1, and also here. So the power of x and y is 1, 1 in the entire system. So which means it is linear in a sense. If the power by any chance become x squared, so if it happened that you have a system of this nature, let's say x minus y or plus y equal to minus 1, and then xy equal to 1. So this system is not linear because there is x multiplied by y. So if you try to figure it out, the power here is actually 1 plus 1, which is 2. So basically that product doesn't allow it to be linear. And in a similar fashion, if you have another system of saying, let's say 1 over x plus y equal to, let's say, minus 1. This is another version of this one, right? So if you do the cross multiplier or law of common denominator by taking x around, you will see that you're going to end up by having xy. So basically it's another form of this one. And then let's say here you have x minus y equal to 3. So you can see that the last equation here is linear equation, but because this one here is not linear, you can characterize it in two different ways. One way, why is it not linear? If we rewrite it, if we write the term is x to the power minus 1, right? Using our notions of writing the fractions in real numbers, because x is in real numbers. So obviously this will tell us that x cannot be 0 in those instances. If you find that with this, I think plus y equal to minus 1. So basically the power is not a positive number, but it's a negative one. So it makes it not linear. Remember, for it to be linear, the power has to be 1, 1 everywhere. The moment the power is not 1, let's say 2, 3, and 4, and so on and so forth, or like with a square root, it's still not going to be linear. So that's the reason why this is not linear, because the power is a negative 1. And even if you have it as like this, a square root of x minus y equal to 1, and then also you can have it as cos of x minus y equal to, let's say, minus 1. So you see, even in those instances, because of the cos of x, you don't have an explicit power, and because of the square root, so that one is also not linear. So now you already know a linear equations in a sense for a simultaneous system of of linear of equation, where you call it simultaneous system of linear equation, right? This is all known, right? Now in this in a similar fashion, I said earlier on that when I gave the earlier system, x minus y equal to 1 and x plus y equal to 1, I said that you can solve. You see, generally if I write it like this, I take y to the right hand side and I say that y is equal to x minus 1, or if you want it vice versa, take y and transpose 1 to the left hand side, it becomes x minus 1. So this usually, you guys, you baptize them in this form. You baptize y, you call it f of x, which is a function of x. That's all that it says. And then you can draw this equation of a line. So if I start to think, because it's x minus 1, when x is 0, what do I get? I'm supposed to get a y equal to minus 1 somewhere here. And then when, look at it, so I'm just trying to think of it in terms of intercept. When x is 0, y is minus 1. And then when y is 0, x would be 1, right? So then basically, I already know that the first point is this one. This is my first point, is 0 and minus 1. So usually you characterize them like this, 0, minus 1. Some other people write them like this, 0, minus 1 in terms of point. And they don't use this because to avoid mixing them with vectors and matrices. And then I said for y is 0, x is equal to 1. So if x is 1, let's say somewhere here, then I can call this when y is 0 is 1 and 0. So basically from these 2 points, it's already enough for me to sketch the line, isn't it? At this 2 point, I can just say that, okay, my equation of the line is going like this because the slope is positive. And then in a similar way, I can do the second one, right? If I do the second one, which is, I can solve, I say y is equal to 1 minus x or minus x plus 1. Let me write it as minus x plus 1 so that you can see that the slope is negative. And then if I try to sketch this one, you see when x is 0, y is 1 here, right? So it's the point 1 and 0. And then when y is 0, what will happen to x? X become also 1, right? Are you guys with me? When y is 0, you solve for x. So x become minus 1, then you divide by minus 1 both sides, you say x is equal to 1. So when y is 0, x is equal to 1. Then you get an equation of a line that is going here. Okay, I missed it slightly. An equation of a line that is going somewhere like this. So it's not drawn up to scale, but it's something close to. So it's not a straight one. I apologize for that. Now, when you look at it, those two lines, they are crossing each other at a specific point. They are crossing each other at the point y equal to 0 and x equal to 1. So it means that is the solution of the system. That's one way of looking at it geometrically. So if you want to visualize it, you say that, okay, the two lines are crossing each other at what point? The two lines are meeting each other at the point 1, 0. The two lines are intersecting each other. Mathematically, we use that word. The two lines intersect each other at the point 1 and 0. So it means that there is only one solution. The two lines are only able to meet once. They are not meeting anywhere else. So that means that the solution is one and only one, is unique, or you call it exactly one solution. So you call it a unique solution, exactly one solution, one and only one solution, because the two lines are only crossing each other once. Apart from that, they will not meet anywhere else. This one will be going in this direction and will be going in this direction, and the other one will also be going into its own direction. So they can never cross each other again. So now, which means that for you to solve a system of linear equation, if you do not have the simultaneous system, but rather you obtain the graph in, okay, and I think I need to tell you that here this is x and this is y because you guys are familiar with this one. So it means that by just looking at the graph, if the lines are intersecting each other once, that you mean that the system has one and only one solution. Okay, or exactly one solution. Now we're going to see another option. So let's say I'm still working with just a simultaneous system. I'll just say x plus y equal to 1. And then at the same time, let's say 2x plus 2y equal to 2. So we can see that for the second equation, if you divide by 2, you're going to get exactly the first one, x plus y equal to 1. So basically, what does that mean? So if you want to sketch it, so you're more than welcome. You can say, right, y is equal to minus x plus 1. I should have chosen a different one just to make because we already know how this one looks like. Okay, so we know that it crosses here at 1 and then it crosses here at 1. This is the point 1, 0, and this is the point 0, 1, right? So that is our x-axis and that's our y-axis. Okay, you see, and then the second one is also the same, the one given by the 2x. So it's also the same, y is equal to minus x plus 1. So basically, there is a line that's going here and then another one going on top of it. There are two of them on top of each other. That's what it means. So the two lines are on top of each other. What can we say about the solution in this instance? What can we say about the solution in this instance? The two lines are on top of each other. Who can tell me what can we say about the solution in this instance?
There are infinitely many solutions.
There are infinitely many solutions. Thank you so much. And the reason why there are infinitely many solutions, because you see, if you pick a point here, the lines are crossing each other here. On top of, not crossing, but they're on top. You pick another point here, another point, another point, another point. Everywhere in this equation of a line, everywhere in this way, where if you want to move around, you pick any point. This point actually, they are on both equation of the line. They're in both graphs. So it means, in a sense, you can pick as many as possible. And that means that if you see that there are two equations, there are two lines, and the two lines are parallel to each other in like this. This one is a specific type of parallel. So these two lines, they are parallel to each other because they are on top of each other. However, one of the line could be facing this way, and the other one could be facing the other way. So it still doesn't matter. As long as they are on top of each other, it means that those two lines are parallel to each other. And then you have infinitely many. Parallel in a sense that one is on top of the other one. Even if there are 3 or 4 or 5, as long as everyone is on top of the other one, that means that we have infinitely many solutions. Now the question is, how do you characterize that? How do you see that mathematically instead of seeing it geometrically or visually? So to see it in another look, you see we reduce the two equations to this one. Or we can keep it as x plus y equal to 1. So I can write it as y equal to minus x plus 1, or I can write it as x equal to minus y plus 1. So it doesn't matter whatever I write it. So it doesn't matter. But let's see why it doesn't matter. You see, when we wrote x equal to minus y plus 1, there is no way we can solve. Each time we give y a value. If you give y equal to 0, x becomes minus 1. You give y equal to 1, x becomes 0. You give y equal to 2, x becomes 1. You give y equal to minus 2, x becomes 3, and so on. So each time you give a value for y, you are finding another x. So it means that thing will never stop. So then mathematically, the question is, we represent this mathematically. We say, okay, we parameterize it. We say, okay, let y equal to t with t any real number. So it means that I can even take it a half, I can take it a quarter, I can take it a pi, or I can take it exponential of 2 or 3, and so on and so forth. So we say let y equal to t with t any real number. Then we solve. We say then it implies that x will be equal to minus t plus 1. Then our solution will going to look like this. It's going to be called a solution set. So first, if we try to write it in terms of solution, it's going to be minus t plus 1, and then t with t a real number. But because this is a family of solutions, there are so many of them. So we describe a different specific notion for it. Then we call it a solution set. The solution set, it will be the set of any x and y in R, x in R and y in R. So both of them, then the couple become R squared. So we call it R cross R, which is a Cartesian product. We see this notion when we get to the notion of set. So now we can understand it. Or we can just write x, y, and then you remove the notion of set. If you are not familiar with it for now, you can write x, y, and then you put a colon, which known mathematically as such that in the meantime. Or you can put something like this. Generally, those coming from French, they write something like that to say such that. However, just putting this should be more than enough to say that x is equal to minus t plus 1 and y is equal to t with t any real number. So usually we call it a solution set. And you can see that for every value of t, you get a y and you get a x. Each time you change t, you get a value for y and you get a value for x. Then that's why the solution become infinitely many solution. Mathematically, that's how you call it. Okay.
Sorry,
now
sir.
Yes, go ahead.
I